Bayes' theorem, we have two types of probability. One is the prior probability. This is an initial probability value originally calculated before any additional information is obtained. Just what we covered in these previous sessions, like we learned the basic probability, addition rule, or multiplication rule. This is all the prior probability. And the second type is a posterior probability. Posterior probability is one of the conditional probability that is assigned after relevant evidence or background is taken into account. And you could see this is also called the Bayes theorem. And for the Bayes theorem, we can use the tree diagram to represent it, just like here. We could write down all the initial probability here, and then we could figure out what is the other given information here. And all these events must be disjoint. Okay, disjoint means like mutually exclusive. And the Bayes theorem is one of the conditional probability. For example, we want to find the probability that one of these initial events. We want to find out this initial event. And based on this subsequent information is given. Okay, one more time. This is a conditional probability. We want to find out the probability of the initial events, and based on the given information, this subsequent information is given. Okay, so this is going to be the Bayes theorem. Okay, let's try this example. The cigarette smoking survey respondents. In Akutan, Alaska, men are 77% of the population. It is also known 11.3% of Akutan males smoke cigarette, while 2.1% of Akutan non-males smoke cigarette. One member of the population is selected at random for a survey involving cell phone carriers. Okay, before we are working on these questions, let's write down the information given. And let's write it down. We're gonna let M equal to the male. Okay, and in this population, we do have a men at 77%. We also have the non-males. So we're gonna put non-males, which is gonna be the complement. And then we have the smoke seeker or not smoke seeker. So we're gonna let C has the smoke seeker, and the complement of C, that's a not smoke seeker. Okay, and let's present all this information using the tree diagram. In Akutan, in this population, we have the male. And also we have non-males. Okay, so the first sentence here, men are 77% of the population. So we could write it down, probability of the males equal to 0.77. Okay, and then we could figure out what is the probability that is a non-male. Okay, non-male. So the male and not male is gonna be the complement. So you could use the complement formula, 1 minus the P of M, which is 1 minus 0.77, and you should get 0.23. Okay, and then it is also known 11.3% of Akutan males smoke cigarette. Okay, and be careful, this is talking about the conditional probability. They're talking about 11.3% of the probability that smoke cigar, given that they are male. Okay, so given that under the situation they are male, they will smoke cigar. Okay, so we're gonna write it down with the conditional probability. One more time, probability that smoke cigar, given that they are males. That will be 11.3%, so 0.113. And then they say, while 2.1% of Akutan non-males smoke cigar. So first, they are non-males, and the probability that they smoke cigars. So it's gonna be here, smoke cigar. And this is also the conditional probability. Probability that smoke cigar, given that they are non-males. That would be equal to 2.1%. So that will be 0.021 here. Okay, now we can figure out all other conditional probability. Here, that will be in Akuchan, they are males and they do not smoke cigarette, right? They do not smoke cigarette. So write it down. Probability that do not smoke cigarette, given that they are males. What is gonna be equal to? Think about it. Either if you are male, either you are smoke cigar or do not smoke cigar. So this is 2 is gonna be the complement also. So you could find it out using the complement formula. Okay, 1 minus 0.113, which is 0.887. And then here, same idea. The population, if you are non-males and you do not smoke cigarette, so that's a conditional probability again. Probability that do not smoke cigarette, given that you're non-male. Okay, and again, this is going to be the complement. So you're going to subtract from 1 here. So that will be 0.979 here. Okay, we just present all the information here using the Chi diagram. Okay, so you could answer the questions from here. Find the probability that the select subject is male. Okay, select subject is a male. We just write it down. P of m equal to 0.77. Find the probability that select subject is not male. Okay, again, this is going to be the complement. So you should be able to figure out this one also. Express the cigar smoking data has a conditional probability. Okay, we do have these 4 guys on our Chi diagram. Okay, now we're gonna do the last one, the last question. That is a much more important questions in here. Okay, although the subject's identity is unknown, the scent of cigarette smoke is detected. Find the probability the select subject is male. Okay, with the questions again. This is the conditional probability. We would like to find the probability that the select subject is male. Okay, let me do it in here. Okay, we would like to find out probability that the subject is male, and based on the situation that the scent of cigarette smoke is detected. Okay, so this is the given information. That's a conditional probability. So we'll be using the conditional probability formula. We are looking for the probability that male and smoke seeker over the probability that smoke seeker. Okay, that's a conditional probability formula. And then we're gonna do it one by one. Remember, this is gonna be the multiplication formula. Okay, so this guy will be equal to probability of male times the conditional probability smoke seeker given that this is a male. Okay, one more time. On the top here, the numerator, this is the multiplication rule, multiplication formula. And then the probability of smoke seeker, we do have a two situation. Okay, it can be probability of smoke seeker given that they are male, or it can be the probability of smoke seeker given that they are non-males. Okay, so you do have a two situation in here. So that's a two possibility for this guy here. It can be male and smoke seeker, or so it's going to be using addition, non-male and smoke seeker. Okay, and this one we're gonna apply the multiplication rule again. So on the top we have the same thing here. On the bottom, write it down plus using the multiplication rule. So probability not a male times probability smoke seeker given that he's not male. Okay, so now we're gonna plug in all this information using the tree diagram here. First, probability of male, so 0.77 times the conditional probability, 0.113 over probability of male times 0.113 again. Okay, probability of non-males. So that will be 0.23 times this guy, conditional probability, 0.979. Okay, then use your calculator. You should find that will be equal to 0.9474. Okay, just like this guy here. My bad. This is the conditional of probability that given is a non-male. So this shouldn't be 0.979. My bad. It should be 0.021 in here. Sorry. This guy. 0.021. Okay, then you should get 0.9474 here. Okay, next example. Airbags are manufactured by the Ace Bags and Cool Company at this weight, and the airbags occasionally kill passengers when they deploy in accidents. Airbags made by Ace Bags and Cool do not kill people at this weight, and one airbag is randomly selected for testing. Okay, for these questions, you could use the tree diagram, just like what we did from the previous example. And I will try to use another method, iterative based theorem. And for this method, you need to create a table. Okay, you can see airbags made by 3 companies, and for each company, the airbags will be kill people or do not kill people. So I'm gonna create a table like this. Okay, company A, company B, company C. for each company, the airbag can be kill passenger or do not kill passenger. And then now you need to make up a convenient number, okay? And I'm gonna make it up. Assume there are 10,000 airbags made by the company A, B, and C. Now you're gonna calculate the number of the airbag made by the company A. So company A is gonna be 57%. So I'm gonna use 10,000 times 57%. I got 5,700. Okay, so 5,700 airbags made by company A. And then you know, airbags made by the A's company do not kill a people at a rate of 99%. So do not kill the passenger here. 5,700 times 99%, and I got this number. Now you need to figure out how many of them is kill passengers. So you could subtract it, right? 5,700 minus this guy, that will be 57 airbags kill passengers. Okay, so I want you guys use this percentage and fill in like this table. Okay, check your answer. You should get this number. Okay, double check. When you add it up here, you should get 10,000. When you add up these two guys, it's also equal to 10,000. Okay, after we have this table, we could answer the probability question here. If an airbag kills a passenger, calculate the probability that the airbag was manufactured by the cool company. Okay, so write it down. This is a conditional probability. Okay, probability that the airbag was made by the cool company given that the airbag kills a passenger. Okay, so plug into the conditional probability formula. And then here we could look at the table. We are looking for the probability that made by the company C and Q passenger. Okay, made by company C and Q passenger. That would be 221. And then what is the probability that the airbags kill passenger? The total of the number of the airbags kill passenger is going to be 382. So you're going to plug it in. You should get this number. Okay. Or again, I'm going to show you guys how to use the G diagram to work on these questions again. Okay. From your workbook, they will ask you guys write it down. What's a probability A, probability B, and probability C? Okay, compare with this guy here. Okay, so you could compare the table and with this information here. If you want to find out the probability of A, okay, probability that make my company A, you could look at this table. If you're looking for the P of A, then look at it. We make it made by the company A. It's gonna be 5,700 over the total number of the airbag, which is gonna be 1,000 or 10,000. So that will be 0.57. All right. Probability of B, same idea. That's 2,600 divided by 10,000. So that will be 0.26. Probability of C, 1,700 over 10,000. So it's going to be 0.17. Okay, so compare. I'm going to get these three numbers from the table also. And then look at here, this part. If I need to find it out, probability that do not kill passenger, given that made by the company A. So that will be the conditional probability. We're looking for this guy. All right. So do not kill passenger and made by company A. That will be 5,643 here over probability of A. So that will be 5,700. You're gonna get 0.99 also, right? 0.99. Or you could do this one. If you're looking for the probability that do not queue passenger, given that make by company A. So doing the same thing, K and A over probability of A. So queue passenger made by the company A, that will be 57 over total made by the company A. So that will be 0.01. Okay, same idea for this plugin here. You could look for all this probability using this table. And then for the last one, this is what they're looking for, right? Probability of made by the company C given that they queue passenger. Okay, so you're gonna get exactly the same answer. Okay, with this answer here. So again, that's up to you guys. You could use the G diagram or you could create the table by yourself to calculate the Bayes theorem.